Good morning. Today we'll be looking at the properties of the scalar product, and this is the last lesson in the higher vectors topic. For vectors A and B, A dot B, the scalar product A dot B is the same as B dot A. Doesn't matter if the letters are the other way around. Okay, just like A times B is the same as B times A. 5 times 3 is the same as 3 times 5. So very similar properties there. If we have three vectors, then A dot bracket B plus C is the same kind of thing as when you multiply out your brackets, but the scalar product is still there in the answer. So A dot B plus A dot C. Here we have a question. Calculate A dot B plus C when magnitude of A is 4, the magnitude of B is 6, and the magnitude of C is 5. If we can see in the diagram here what the angles between the vector AB and the vector BC are, and we can see as well that the vectors are all pointing away, so they're all set up. We can use these angles as they are. Okay, so let's start with the question with the brackets, multiply that out, which gives us A dot B plus A dot C, and then we're going to use the formula that contains the magnitude and the angles. And we've got two of them to work out. Okay, we've got the A dot B one with magnitude of A times the magnitude of B times the cos theta. And the A dot C one will give you the magnitude of A times the magnitude of C times the cos theta. Now be very careful because the theta, the angles, are the angles between your vectors. The first one is the angle between the vector A and B. We can see from the diagram. The angle between vector A and B is the angle 30. And then for the next one, it's the angle between A and C. Now look carefully at the diagram. What do you think the angle between A and C is? Be very careful. It's not 15, it's 45. It's A and C. A and C is the 30 plus the 15 together. So just be very careful with that. Okay, so we multiply this together. Now, if you had already done exact values from the trigonometry topic, you would be expected to do this without a calculator. But just now, because we haven't done that, you will use a calculator. Now, you might get the answer given like this, many calculators now do, or you might get a decimal equivalent. Unfortunately, if you get the decimal equivalent, you're losing the opportunity to simplify your surds, which is what you would be expected to do for the final exam, because a question like this would be a non-calculator paper and you would be dealing with exact values. So the next one here gives you 20 times 1 over root 2. So for this, at this stage of the higher course, you're okay to put that into the calculator, okay? Now let's put this together here. The 24 is like the top of the fraction 24 over 1. So the whole number multiplies just by the top of the fraction. So 24 root 3 over 2. If you were to think of that as a fraction 24 over 1, the 1 times the 2 would just give you a 2. Now the 24 and the 2 simplified together, and that's why our answer there has a 12. Then the next one just goes together. The 20 multiplies by the top of the fraction, so we have 20 over root 2. Now, again, if you had to use a calculator and have decimals, you would just type in 12 times root 3 plus 20 over root 2 to check that you've got the same equivalent answer as a decimal. However, you are losing an opportunity because you would be expected to simplify the second surd. In higher, you never leave a surd on the bottom. You always rationalise the denominator. And you learned how to do that at National 5. So let's bring this up to the next line here. And I'm just going to write the whole thing again. But we're going to look at the part that we don't want to keep here, which is the root 2 in the bottom. And that's exactly what we're going to multiply top and bottom by to get rid of that irrational denominator. So we multiply by root 2 over root 2. So that means the top becomes 20 over root 2. And the bottom becomes 2. Root 2 times root 2 is 2. So that's a skill from National 5 that you should remember. Then the 20 over the 2 becomes a 10. And now we have two surds that can't go together any further, okay? And we don't have an irrational denominator. We've now rationalised the denominator, and that's our final answer. But again, if you have had to use a calculator that's only giving you the answer as a decimal at this stage, then just, if you see that at the back of the book, just type in 12 times root 3 plus 10 times root 2 and check it is equal to the decimal that you have. And at least you know you're doing your your vectors work correctly, and you will get more practice at simplifying your surds and doing exact values later on when we've covered the exact values part of the course. Okay, so we're on to exercise 13U today. Here's your selection of questions, and as always, ask your teachers if you have any issues, any questions that you need help with, and send photos of your marked work in so we can check you're working. Okay, so good luck with everything and take care.